Hi everyone, welcome back to another Sean's tutorial. This tutorial is image mapping by using Rhino Grasshopper. I think you guys must familiar with some kind of like that facade system with some images inside. Just try to have a crack with what we can do, how we're gonna create something like that effect with simple script. Also, I will attach the script under the YouTube channel. Let's get started. So first of all, I just draw a curve, a closed rectangle, whatever, so I can map with some paneling system inside. So what I need to do, I need to reference that curve. Set one curve, set this curve. So once I set the curve, but at the moment I working on y and x plane, so that is need to needs to be know what plane you're working on, because we will rotate it along the x. So you need to if you want to tilt it in 90-degree, turn it to x and z plane, so it will be another and just add another components called in the vector components called that xy plane, yz plane, xz plane. Yeah, just need to choose what planes you need to rotate to. So once I got the curve, I start to paneling that that surface with lunchbox, because lunchbox is kind of like integrated in newer Rhino system. I maybe use something like a brick system, or yeah, or we can use the generic chord, or we can use whatever system, but just need to consistent with spacing, so when they rotate it they can get the image effect. So I maybe put a number style as 10 to 100, so maybe I just put 40 right now. They both have the same number, so I kind of like have a brick panel pattern, and then I will go into, so we need to get the center point of each panel. We use the area commands. Maybe that's a bit bigger, that's a bit dense, so just keep it as a 20, and then we have the center point of each panel, and then we need to using bounding box to mapping the whole facade, if that's a facade. Yeah. What it does is they got the two different options per object, or a union box as a mapping the whole things, because we need to use the whole thing to map out which surface is which. So and the next step will be close point to surface, a surface close point. Let's see, surface closest point, yes. And then we use that center point to connect to the point, and use the whole bounding box thing as a surface. And then we have we have to reparameterize the input from the bounding box. The reason why is we're getting the number as it's not random, but it's really hard to working on that 1 to 149 domain. So what we need to do when we change it to parametric noise, it will be turns into 1 to 0. So all the numbers will be mapping to 1 to 0. So that is what we need to do. And then we got the domain and we got the every center point, and then we can use insert the image using the image sampler. So let me pick that cat image we used before, and then we maybe want to use the black and white as the how to interpret it, the image. Somehow I find out that always being the best result. It also depends on what texture, what material you're using. So we plug that UV point from 1 to 0 to that image. So we will gonna have that image. I mean we will gonna have that value modified by the image. So we get another set of number to representing how dark is per inch, if how dark is per inch or how dark is per tile, per pixel, because we've been mapping 20 by 20 UV. That is our pixel. So what we need to do, we need to remap those value into 0 to 1. So that's the value we need to remap. So the purpose in this exercise is to rotate that to that break pattern to according the how dark it is the image. So the source domain is 0 to 1 is okay, and the target domain, I think we need to have a rotation number. So a degree of the rotation, maybe use 20 degree, sorry, minus 20 degree to 20 degree. So yep, so the result with mapped number will according that to 20 degree to minus 20 degree. And beside that, I think we can put another parameters to control it if that wasn't success, or we can scale it in a way. It doesn't really matter. So I maybe give a 180 degree, 0 to 180 a slider if we need to use it. And then there's a basic setup. So the main thing, the how to make that thing happen, we got a number, we got a parameter. How to make this thing happen is we need to put a rotate command, rotate command to rotate each geometry. So we need to have each panel rotate to the different angle. Also in the center, we will have that center in the plane parameter, because the plane parameters I think is set up by x, y. We want to have that in the y set as I mentioned it before. So we need to put that value into YZ. So center it, YZ, put it back. So we start to getting something to see. Maybe we're gonna hide that and hide that. Let's see if we put a server geometry. Let's put a geometry here, and then put it inside, and then maybe better to have a preview because we're working on a angles, so will be good to have a preview, material preview, so to achieve the best result, preview result. We can know what we're doing. So it may not be perfect right now, but when we densifying the pattern, we start to see that image. If not, we better to rotate it. 1 second. Sorry, my bad. So maybe I just preview it. Just view that. If that works. Or we 0 to 1, 20 to 20. So if that's the case, we need to check the value. Is it what we doing? Maybe is too narrow for rotation. Maybe you can put 60 degree for each one. So see how can we interpret that image into. Oh, sorry, it's a really major error because I have to put it into degree. So when it's in a degree, they reckon it's rotate in a certain degree, not just a lumber. Now we having a JPEG image with a brick pattern rotate. Alright, thanks for watching. I'll see you next time.